In this demonstration video, the math peripheral will be introduced that performs the various mathematical operations such as multiplication, division, and more. The general behavior of our peripheral is primarily receiving the numbers from scomp, storing the result of the operation, and releasing it when read.
This is a clock application that uses the divide and remainder functionality of our peripheral. Toggling the rightmost switch increments the minutes by 1. The application stores the minutes value, and whenever the display updates, it asks the peripheral to do two things. It uses the floor division by 10 to get the tens digit of the minutes, and it uses the remainder of 10 to get the ones digit. For example, if the minutes value is 29, the peripheral returns 29 divided by 10 floored, which is 2 for the tens place, and the remainder of 29 divided by 10, which is 9 for the ones place. To keep the minutes within the range of 0 to 59, the application uses the remainder of minutes divided by 60. So when the value hits 60, the remainder becomes 0, the minutes reset to 0, and the hour increments by 1. The second rightmost switch increments hour by 1. Hours work the same way. The remainder operation keeps them within the range of 0 to 11. When the hour reaches 12, taking the remainder flips it back to 0 and switches between AM and PM automatically.
The powers of 10 application uses power and remainder features of our peripheral. At the start of the powers of 10 game application, our peripheral uses its remainder operation to randomly select an exponent k between 1 and 3. Once k is chosen, the power operation computes 10 raised to that exponent. The result, either 1, 10, 100, or 1000, is displayed on hex 0. The player then computes their own exponent n using the same peripheral. N is encoded by the first two switches. No switches up means 0. The first switch up represents 1, the second represents 2, and both together represent 3. The peripheral calculates 10 to the power of n and compares it to 10 to the power of k. If they match, the score increments by 1. If not, the score stays the same. The score is displayed on hex 1, updating only when the player's exponent matches the target. This makes success immediately visible. Functionally, the peripheral provides two key operations: remainder, which reduces values to a chosen range, and power, which computes 10 raised to an exponent. Together, they extend scomp's arithmetic capabilities. Scomp interacts with the peripheral through a simple high-level interface. The program sends values to the peripheral, and the peripheral responds with results that can be immediately used. This design makes the peripheral easy to integrate into applications. For example, the peripheral picks exponent 1, so 10 to the 1 shows as A in hex. With no switches up, my guess doesn't match, so the score stays the same. In the next round, the target is 1, and 10 to the 0 equals 1. Now, no switches up matches, and the score increments.
In this demonstration, a calculator application is performed to illustrate peripheral's multiplication, division, remainder, absolute function, power function, and error checking mechanisms. Before the actual examples, we'll go through a basic steps on how our peripheral will interact with the software. User first select the calculation mode using a switch and enters two values for a mode, except for an absolute value function that only requires one value. During this time, the values are received by our peripheral that performs arithmetic and stores the result. The result that is either numeric or error flag is then released for scomp to read. This example illustrates our peripheral's multiplication function. For example, the user puts in the value of 4 and 2 in sequence to produce 8 on 7-segment display. Our peripheral also implements the error flag associated with this multiplication function. For example, when a user multiplies a very large number in sequence, in this example 256, and 256, the error flag shows up as FFF1 on the 7-segment display, signaling the user that they produced a result that is outside of the range of what ESCOM can hold. Next, our peripheral implements a floor division. For example, when the user puts in the value of 8 and 2 in sequence, 4 will be displayed on the 7-segment display. This subsequent example illustrates the implementation of the division by 0 error flag. For example, when the value of 8 is divided by 0, the division by 0 error flag will show up as FFF2 on the 7-segment display to signal the user that they have done an illegal calculation. This example illustrates peripheral's remainder function. For example, when the user puts in the value of 6 and 5 in sequence, 1 will be displayed on the 7-segment display. This example shows the absolute value function of the peripheral. The user puts the value of -32, and the magnitude of that number, which is 32, is displayed on the 7-segment display. This example illustrates peripheral's power function. For example, when the user puts in the value of 6 and 2 in sequence, which corresponds to base and exponent respectively, a value of 36 is computed, which is converted to 24 in hexadecimal on 7-segment display. Associated with power function is the power overflow error flag. When the user puts in the two values in sequence, especially when the exponent is large, in this case, 8, 5 to the 8 is well outside of the range of what ESCOM can support, so error flag of FFF3 is displayed on the 7-segment display. Another error flag associated with the power function is the negative exponent error flag. For example, when the user puts in the negative number as exponent, which is -2 in this case, the result of -4 to the -2 results in the error flag of FFF4 and gets displayed on the 7-segment display. This summarizes all of the error flags. The final demonstration is the peripheral's signed multiplication and division. Earlier in the demonstration for calculator application, only positive numbers were multiplied. Our peripheral is also flexible with negative numbers. For example, when 6 is multiplied by -4, the result is -24, displayed at the most to right 7-segment display. The demo concludes with the signed division. For example, when the user divides -6 and 2 in sequence, the result is -3, again displayed on the most to right 7-segment display. In summary, our peripheral provides wealth of functions and error flag functions used to build application and even for debugging purposes when they make mistakes along the way.